Be explaining what a confusion matrix is and the basic concepts behind it. So a confusion matrix is used for logistic regression to create an error distribution table. There will be two confusion matrices, one for the test data and one for the training data. The idea behind a confusion matrix is that it'll test what's predicted versus what actually happens, and it'll give you a percentage of how many times that will occur. So let's look at an example here. So this is a coding here, but we're going to ignore that for now. So in this case, we're looking at the training data. So I'm going to focus on this here. The columns are labeled train pred, which is the predicted values, and then train actual, which is what actually occurs, percentages, how many times this occurs. So if we look at the zeros and the ones, they're basically failures and successes if we're saying something isn't going to happen or it is going to happen. Looking at this first line, it's showing us when we predict something's not going to occur, so it's 0, and it doesn't actually occur, so it's 0 again. This occurs around 31.4% of the time. Line 2, we have it's showing us when we predict something is going to occur, so that's a 1, and it doesn't actually occur, which is a 0. This occurs about 27.1% of the time. In line 3, we have 0, so it's predicting that something's not going to occur, but it does actually occur. That's the 1 here. It means we're incorrect, and it's showing us this happens about 27.1% of the time. And then in line 4, it's showing us that when we predict something is going to occur, it's the 1, and it actually does occur. It's a 1 again. It's going to occur about 14.3% of the time. It's also important to notice that all of these percentages add up to 100%. And in another video, we'll explain how you compare training and test prediction and accuracy and stability.